Welcome back, chemistry fans. Today, what we're going to do is Unit 6, Topic 2, homework. So let's jump right into it here. This is, again, stoichiometry. And this time, however, we're going to be working with units that are not grams. So we have to adapt to other units that are in our mole map. Now, what I start with and I suggest is that you still write the amounts given over the balanced reaction to just focus you and tell you where you're headed so that you don't have issues as we move forward. So I'm going to work this twice. I'm going to work it once with dimensional analysis. Then I'm going to show you the exact same process with setting it up as ratios. In this dimensional analysis, I've got 6.7 moles of O2. And what I'm going to do then is recognize that that coefficient from the balanced reaction, the 17, those are actually the number of moles of O2. Now, what I want to convert this into is grams of H2O. So I have to use the number of coefficient, the mole amount of H2O. But if I stop right there, I'm only going to solve for moles. So what I have to do now is say for every 1 mole of H2O, there are 18 grams of H2O. Now I have the process of converting from moles into moles of H2O into grams of H2O. So 6.7 multiply across the top times 10 times 18 divided by 17, and we end up with 70.9 grams of H2O. Now, if I were just to try and solve this as a ratio, I would have 6.7 over 17 times 1 because there is no weight for the O2. So there actually isn't even a 1 there. It's just not there. Is equal to X over 10 times the weight of the water because we are converting it into grams. All right, crisscross applesauce, and you end up with 70.9 again. All right, now number 2, use the same balanced equation, but we're going to start with 88.4 liters of C6H10. I'm going to change my pen color so we can distinguish a little bit about what we're doing here. So 88.4, and this is in liters, and now we're going to grams of CO2. So I'm going to start again with dimensional analysis, 88.4 liters. And it is of the value or of the substance C6H10. We're going to carbon dioxide as mole amount. So we're going to use the coefficients as mole ratio. But first, I've got to use the liters. I've got to first convert out of liters into moles. So I need to remember from the mole map, 22.4 liters of C6H10 will give me 1 mole of C6H10. Then, for every 2 moles of C6H10, there were going to be, I believe the value was 6 moles. No, it's 12 moles of CO2, 12 moles of CO2. Now, I'm not done with moles because it wants it in grams. So for every 1 mole of CO2, there are 44 grams of CO2. I get those values off the periodic table. So I'm going to do 88.4 times 1 times 12 times 44 divided by 22.4 divided by 2, and I end up with 1,041.9 grams of CO2. Now, if I want to do this as a ratio, I've got 88.4 over 2 for C6H12 times 22.4 is the conversion factor equals X over 12 times its conversion factor of 44, cross multiply, and you end up with the exact same answer, 1,041.9. This is everything that I wish to share with you today about our homework for Unit 6, Topic 2. Thank you so much, and I will see you in class soon. Bye-bye.